before we begin the lesson, let's imagine that we have this box. This box is called a function machine. I put something in, I get something out. The function machine does something to it. I don't know what it is. I have to see, okay, what did I put in? What did I get out? What did the function machine do to it? So, say I have this. Put it in my function machine. Out comes this. What happened? What did the function machine do? Now there's actually two things it could have done. Carla, what's one thing the function machine could have done?
It could have had added 6 to the 3.
It could have added 6. Is that the only thing the function machine could have done? Colin,
No.
what else could the function machine have done?
It could have multiplied by 3.
It could have multiplied by 3. Either one of those would be correct. Function machine did one of those. We're not really sure. But the function machine is doing the same exact thing. Could be add 6, could be multiply by 3. Now I put a 6 in, and out comes a 12. It did the same thing. Which one did it do? Did it add 6 or did it multiply by 3? Mason.
It added 6.
It added 6. Very good, because 6 times 3 is not 12. What is 6 times 3? Class?
18.
18. Good. So, I know now that the function machine added 6. What's going to come out if I put in an 8? If I put in an 8, what is going to come out? We know the function machine is adding 6. Kingston, what's going to come out of our function machine? We're putting in an 8. What do you think is going to come out?
16.
Not 16. Try again. Use your fingers if you need to and count up. Remember, when we count up or count back, we don't count the number we start on.
14.
14. Let's find out if you're right. We put in our 8. The function machine adds 6. And we get out 14. Good. What if, so now our function machine, I've reprogrammed it, does something different. I put in 22. Oh, yeah, you can go in. Okay, so everybody, finger or pencil on example 1. Okay, read in your head while I read out loud. We're going to pause at every period and imagine it. Mr. Mathis is creating a table to show how input numbers are changed, okay? Well, I see this table right here, so I don't even need to visualize. I'm just imagining a math teacher, Mr. Mathis, drawing this for the first time. Write an equation that describes the pattern in the table. Complete the table. So, what we're going to do is we are looking at the input and then the output. They're going to give us a couple so that we can make sure we know exactly what to do. If there's only one, we could subtract, we could divide. We could add, we could multiply. But having more than one output will tell us, okay, we can't be doing that first thing I thought. We have to be doing the second thing I thought. Okay? And then we're going to make an equation out of it. So, let's look. In our input column, which they have a variable for, x. So we know when we write our equation, we're going to use x to mean our input. And that just means any number in this column. And then we have our output, which they are going to use a y to represent. So in the first one, in the input we have 2, and out comes a 9. What could we be doing to 2 to get 9? Victoria.
We could add
You can count up and count back.
6,
Let's find out. 2, 3, 4, 5, 6, 7, 8.
7.
So is it add 6? No, it's add 7. 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we could add 7 to get 9. Well, what could we do to 4? Is there anything else we could do to 2 to get 9? Zari? Oh, you turn your camera off.
We could multiply by 3.
2 times 3 means the same thing as 2 plus 2 plus 2. Zari, what's 2 plus 2?
4.
Plus 6 plus 2?
6.
So that means 2 times 3 is 6. So can we multiply 2 by 3 to get 9?
No.
No. So is there anything else we can do to 2 to get 9? Colin?
No.
No, there's nothing else. So we know, okay, it's probably add 7, but let's check. Well, next we have 4. We put in, sorry, don't forget to mute. We put 4 in, out comes 11. What do we have to do to 4 to get 11? Michaela? Add 7. 4, 5, 6, 7, 8, 9, 10, 11. That's probably our rule. But let's check. Next, our input is 6. Out comes 13. I just pulled Victoria, but you got to do the first one, so. I just pulled you guys, so I'm going to pull you out. Zari, let's check. 6, what do? We put 6 in. Out came 13. What do we do to 6 to get 13?
Add 7.
Add 7. Let's check. 6, 7, 8, 9, 10, 11, 12, 13. Yep. So that means the rule is to do what, Mason?
What was the question?
What is the rule? 2, when we put the 2 in, out came a 9, which means we added 7. When we put in 4, we got out 11, which means we added 7. We put in 6, we got out 13, which means we added 7. So what is the rule, Mason? To do what?
Add 7.
Add 7. So the way we write an equation, look at this last part. You don't have to look at it up here, but you can look at it in your book. Right after rule, where we figured out it's add 7, we have our equation. Pay attention to this equation. We see the variable for the input comes first, because that's what goes into the function machine. Then we have the rule. Because remember, when we did our function machine earlier, we had our input, and then our function machine, and then our output. Equations work in the same order. We have input variable, rule, function machine, output variable, what comes out. So do you see, the equation is set up the same way as our function machine. Input, rule, output. Does everybody see that? It matches. I'll do it one more time. This time I'll have the pointer so I don't block. Input, rule, output. But instead of having numbers, you're putting whatever variables they give you. So you have to make sure you're using the correct variables in the right place. So for this equation, our input has the variable x. Then comes our rule. We know we're adding 7. And then here comes our output. Equals y. So we know anytime we replace this x with one of these numbers, we're going to add 7, and out is going to come one of these numbers. So does everybody see how the x represents all of these numbers in this input column? And the y is going to represent all of these numbers in the output column. Does everybody see that? And you imagine the rule right here. Does everybody see that? So now, let's use the rule to complete the equation. We know we're adding 7. Our next input is 8. Aaron, what is 8 plus 7? 15. Next, we put in 10. Zadie, what is 10 plus 7? 17. Next, we put in a 12. Carla, what is 12 plus 7?
19.
19. So, that worked. That means the equation that describes the pattern, is what? Remember, an equation has an operation symbol and an equal sign. So what is the equation that describes the pattern? We already figured this out. All you have to do is move it from one place to another. Aaron.
X plus 7 equals y.
X, which is the input, plus 7, which is the rule, equals y, which is the output. Okay, we'll go ahead and take a break for library. Zari, can you please tell Mason the info to get on library? And then Carla, you can go ahead and go to library, come back at 12:35. Mason, Zari's going to tell you the info so that you can get on the library Zoom. Because I don't actually know what it is. I guess I should find that out. And then you, the two of you go to library and come back at 12:35. Okay?
Okay, bye.
Bye.
I'm sorry. When you just...
Okay, so everybody look at example 2. Finger a pencil, showing me that you are ready. Okay? Let's read this problem. Remember, every period we get to, we're going to stop and we're going to visualize. A pizza shop offers $3 off for any order over $10. Okay, so I'm imagining I'm at a pizza shop. Any cost, like anytime you order pizza and the cost is over $10, you automatically get $3 off. Okay? Use the rule and equation to find the next 4 output numbers. Okay, so this problem is a little different from the first one. We knew a couple of the inputs because it said, we knew what was going in, and we knew a couple of the answers to what was coming out. We had to find the rule. In this case, we already know the rule. We know that any time the order or the amount is over $10, we take $3 off. What operation means taking money off? Michaela? Subtraction. So that means we're taking whatever the total cost is, subtracting 3 to get the new cost. So the input is the total cost because that's what we're putting in. The rule is subtract 3 because that's how much money gets taken off of the order. The output is the final cost. So they give us the rule, which is to subtract 3, and they give us the equation. Input, which is the total cost, minus $3 equals the output, which is the final cost. So they already told us Say you order pizza and your total bill is $11. $11 is greater than $10, right? So that means the pizza shop is going to offer us $3 off. 11 minus $3 equals $8. So now we just have to follow the rule. We have all the inputs. We have to follow the rule. So if the total cost of your food is $12, we know the rule is subtract 3. So we replace that variable for input with the next number on our table. The rule is the same. When you are working with one table, the rule never changes. The only things that will change are the input numbers and the output numbers, but what you do between never changes. So we already know. We're going to be subtracting $3 each time. That doesn't change. You see some people writing that, I see some people not. So, if the total cost is $12, after the $3 discount, how much is the customer going to pay? Michaela? $9, because $12 minus $3 is $9. Now, if the total cost of the food is $14, and then they get the $3 discount, how much will the customer end up paying Kingston? $11. So you imagine you put the $14 in the function machine. The function machine subtracts $3. Output comes $11. Okay, if the total cost of the pizza is $16 and then the restaurant gives the $3 discount, what is the final cost for the customer, Smith? $13. So you put $16 in the function machine. The function machine subtracts $3, and out comes $13. Okay, the total cost of the pizza is $18. The store gives the $3 discount, and the customer pays what, Cullen?
$15.
$15. We put $18 in the function machine. The function machine subtracts $3. Out comes $15. So, now we have to answer this question. The next 4 amounts are, Lena?
What does it mean by that?
It means the next 4 amounts. So the next 4 amounts of money are what? We already knew the first amount of money was $8. So what are the next 4?
9, 11, 13, 15.
Slowly.
$9. Oh. $9. $11. $13. And $15.
So the next 4 amounts, that does not include the original, that's why it says the next 4, are $9, $11, $13, and $15. Okay, now we're at the observation point. When it comes to input-output input-output tables, your pattern can go up and down. We know when we have an input-output table, to find the rule, we go from input to output, right? We would not find a rule by going from input to input to input to input, or output to output to output to output. That's not how input-output tables work. The rule goes from input to output. But a pattern observation can be what you see in the inputs, what you see in the outputs, something different you see, whatever. You just have to be specific. So, raise your hand if you see another pattern in this chart. Come on, guys, think. There are lots of patterns. Everybody should have their hands up, except for Mason, who may not be able to see. There are lots of patterns. Come on. I am not allowing just 2 people to find a pattern. There are a lot of patterns. There are a lot of observations you can make. Look at the numbers. You can figure out what happens. What's a pattern about just the input numbers? What pattern do you see in just the output numbers? And there are many different patterns for each one. There's not just one pattern. Carla, what's a pattern that you see?
I see that on the output, after the 8, when it keeps going, it gets bigger and bigger as it goes.
So we can say the output terms are, what is the math word for getting bigger, Carla?
Increasing.
Increasing. Okay, what's another pattern? Zadie. Oh, I just picked your stick and accidentally dropped it. Zadie, what's another pattern you see?
In the output, the numbers when you add 2 to 9, it gets 11.
But that has to work every time. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 2 is 15. But is 8 plus 2 9?
No.
So does that work?
No.
No. So it would have to be every time to say that the output numbers increase by 2 every time. But unfortunately that doesn't happen from 8 to 9. Victoria, what's a pattern you see?
Okay. I saw 2, but then I realized, but it's kind of messed up. Do you want me to tell you the one?
Just tell me one. Pick one.
In the input section, there's in the tens place it's 1 1 1 1 1.
Okay. So input terms have 1 in the tens place.
I wanted to know if this actually counted, but you don't have to write it down. It goes like in the first one it goes odd, even, and then the rest it goes even, odd, even, odd, even, odd, even, odd.
Do you mean from input to output?
Uh-huh.
That is a very good observation. Victoria wasn't sure if it counted, but it was a very good observation. Every time the input is odd, the output is even. So anytime one column is odd, the other column is even. Do you see that? Here we have an odd number in the input, even in the output. Odd in the output, even in the input. Odd in the output, even input. Odd output, even input. Odd output, even input. So that is a very good observation. So we will go ahead and write that. We'll say when the, let's see, input is even, the output is odd. And it works the opposite way too. If the output is even, the input is odd. Okay, sorry, we had to go ahead and start. You can just watch this part of this video later to get example 2, because we just finished example 2. Okay, So just watch the video later. You can skip to just example 2 and then stop it when example 2 is over, okay? Kingston, what's one more observation, and then we're going to move on to the guided practice.
Well, if you add 3 to the output numbers, you get the input.
Okay. I'm not going to write that as an observation, but that is something, yes, because subtraction, so Kingston noticed that if you add 3 to the output, you get the input. And yes, that's true because subtraction and addition are what type of observations? What is that math word, that math term for addition and subtraction, these types of observations? Division and multiplication are also these types of observations. Smith?
Inverse operation.
Inverse operations. It means they're opposite of each other. If you add a number to get an answer, you can subtract that same number from the answer to get the first one. Okay? So they're opposite. They're backwards. So 11 minus 3 equals 8. Well, 8 plus 3 equals 11. So they're opposites of each other. It's the same with division. 2 times 3 equals 6. 6 divided by 3 equals 2. So they're inverse operations. So yes, that is true. But if you see that as an observation, make sure that you can find another something too. Because that is kind of the rule, because they are inverse operations. Okay, let's go ahead and move on to the guided practice, and then we're going to do number 2 and 3 on the independent practice together. However, if after, actually not number 2 and 3, we're going to do number 2 and 4. But, actually no, okay, change my mind altogether. We're going to do number 1, and then we're going to do number 4, and then you're on your own, okay? Okay, so, number 1 says, write an equation that describes the pattern. Then use the equation to find the next 3 output numbers. Well, I have input and I have output, and I already have my variables. I know where those input and output variables go. I have 3 spaces in my equation. Where does my input variable go? Look, you can look at example 1 and 2 to look at those equations. Zari. Well, actually, I'll pick somebody who's here, and then you can pick up later, okay? Victoria. My input variable is A. Does the input variable go in the first blank, the second blank, or the third blank? First. Where does my output variable go, Victoria?
Your output goes in the last one.
It goes in the last one. What always comes between the second and third blank?
Your roll.
I have 1 blank, 2 blanks, 3 blanks. Look at the problems. The rule goes in the second blank. What comes between the rule and the output variable?
Oh,
Look at the problems.
and
An equal sign. So, everybody listen. You can go ahead, when you have to come up with an equation, it gives you the variables. So you can go ahead and set up what you know. The input variable always comes first. Input variable comes first. The output variable always comes last. The rule goes in the middle. And then an equal sign comes between the rule and the output variable. So an equal sign comes between rule and output variable. So there you go. Now you have your formula. That means all you have to do is plug everything in. That's all you have to do. Now you know the formula. It's going to be the same every time. Input variable first, rule in the middle. That means operation symbol and whatever you're adding, subtracting, multiplying, dividing. Equal sign comes between, and then the output variable. Always. Yes. Unless they're trying to be a little tricky and they flip-flop it, but then it's going to be in the same order, just backwards. But it's the same.
Is that supposed to be rule after between?
Yes, sorry. It is supposed to be rule, and it says roll, which is not a word. Yes. So equal sign between rule and output variable. So now we just have to figure out the rule, right? We've got our whole equation. We just have to figure out the rule and then continue it. So, Victoria, what can we do to 5 to get to 9? Add 4. Is there anything else we can do? No. But let's check what we know just to make sure. Before we say our rule is add 4, let's keep checking just to be sure. If we add 4 to 9, will we get 13? 9, 10, 11, 12, 13. Let's just keep going because we know, let's check our last one. If we start with 13 and we add 4, will we get 17?
Yes.
13, 14, 15, 16, 17.
For the 9 one, I forgot to say yes because it's
Okay. So that means our rule is what, Victoria?
add 4.
Add 4. Is everybody with me? Does everybody understand what's happening? So now, Victoria, finish it out. We know, are we going to change our rule just because we don't have these outputs? Is our rule going to change? If we are working at one table, will our rule change, class?
No.
No. It will not change until we get to a brand new table. Just because these are empty and we're filling them, does that mean it's a brand new table?
No.
No, it's just a brand new output. So what do we do to 17?
Add 4.
Which equals
21.
21. What do we do to 21?
We
Add 4, which equals
25.
25. What do we do to 25?
Add 4.
Which equals
29.
29. Very good. Everybody with me? Do you have all this written so that you know exactly where everything goes? Yes, Victoria.
I think this is an observation, but every time you get an output, it gets put in the input section.
That's more of just those are the numbers they chose.
Okay.
Because input is just whatever numbers your math book chooses. There will not always be a pattern from input to input to input to input or from output to output to output. So never, ever, ever look for the rule to be from here to here or here to here. Does everybody understand? Always look for the rule from the input to the output. Now sometimes it's sideways like this, sometimes it's up and down like in example 2 and example 1. But just make sure that you're looking for input and output. Yes, Zadie.
And also, if you do that every time, like expect the numbers, the answer to be there,
Mhm.
and then you do that, and then you get to the last one, and you're like, oh, there's not another one, so how do I know?
Exactly. That is why you must always look from input to output. Okay, I'm pretty sure that I'm going to have to re-log in. So go ahead and start working on number 2 and 3 while I get number 4 ready. Okay? Okay, so let's look at number 4. This looks a little different than what we've seen. There's no word problem. We only have one output, but they give us the rule. So they already told us what the rule is. They already gave us the equation. We're not having to write the equation. We know F plus 3 equals H. Our input variable is F. Our output variable is H. So that means input plus 3 equals output. They did the first one for us. 3 plus 3 equals 6. So, Smith, help me with the the rest of this problem. Next, we have 6. What do we do to 6?
Add 3.
6 plus 3 equals
9.
9. I'm going to pick, we'll see. Next, we have 9. What do?
We add 3.
9 plus 3 equals
12.
12. Next, we have 12. Tell me the equation.
12 plus 3 equals 15.
12 plus 3 equals 15. Last one, tell me the equation.
15 plus 3 equals 18.
Very good. So, any questions? Kingston.
I would probably say the same thing Victoria said about the input,
Mm-hmm.
the output, and input part.
Yep, the output is going to the input. Sometimes that's just how the math book chose to set it up. You could make that observation, but just know that will not be the case all the time. Does everybody understand? Because we do not look from input to input to input to input to input, or output to output to output to output to output, or even this output to this input. Okay? Now, for those of you that feel like you are ready, go ahead. For those of you that feel like you need a little bit of practice, let's do number 2 and number 5. No shame in needing practice. Who would like to help me with number 2 out loud? Aaron, I saw your hand first. There's still number 5 that we're going to do together. Oh, but wait, before you start, let's talk about the independent practice, and then we'll go back and do number 2, Aaron, and then somebody will help me with number 5. So, numbers, everybody look. Pause and look. Numbers 2 and 3 are just like the guided practice. Numbers 4, 5, and 6 are just like the one we just did together, number 4. Numbers 7 and 8, you have to create your own input table. So, that means you have to create this yourself. They give you the rule. You create your own. Make sure that you have the title input, so you need it to look exactly like this, just with different numbers and a different rule. Also, pay attention to the variables they use. Remember, the first variable is going to be which part, the input or the output? Zari.
The input.
The input. And the last variable in the rule is going to be the, Zari?
Output.
Output. You know what? Let's do number 5 together. Number 7 together, because I want you to see exactly what that should look like. We're going to do number 7 together. Yes, Smith.
I was going to ask you before you said we were going to do number 7, I was going to ask how many boxes do you want us to have?
Okay, I'll show you. Okay, number 7 says create an input-output table for each equation. Now, we can't see this one because of the zooming and everything, but you can see it on your book. So we know we need a tall rectangle. I'm going to make it go all the way from the bottom of number 7 to the top of number 9. I'm not going to do a sideways one because then I might run out of room. I'm just going to do a tall one. I know I have to have, look at number 4. I know I have to have a box at the top that goes all the way across for the rule. I don't know why I did that R like that. So I used to do it in like middle school and high school. What is the rule? Aaron.
Y plus 4 equals Z.
Y plus 4 equals Z. Then the rest of it is split into 2 columns. Because we have an input column and an output column. Before we start putting numbers, let's put input. And Aaron, what variable are we using for input?
Y.
Y, because that's our first variable. Remember, our first variable is input, our last variable is output. Which means our output variable is what? Aaron? Z. So there we go. Now we have the first one. I would like you to do at least 4. So, 1, 2, 3, 4. At least 4. If you'd like to do 5, 6, whatever, just don't go overboard. and spend 100 years because you want to do 27 inputs.
27.
Now, Aaron, you get to choose any inputs you'd like. What would you like it to be? What would you like your 4 inputs to be?
27.
Okay, 27. They do have to go from least to greatest, though. So make sure your numbers get bigger. But they don't have to be a pattern. Remember, we're not looking for a pattern from input to input to input to input. So they can be whatever you want. What should come next?
32.
32. 44. 52. So there we go. There's our inputs. Yes.
Do we have to do the same numbers?
For now, since we're doing it together, yes. But for number 8, you get to do whatever ones you want. Okay, Aaron, now we have to find the output. Well, our first input is 27. What's the rule?
We're adding 4.
Add 4. So 27 plus 4 equals
31.
31. Next, Aaron, what are we doing to the input? 32?
We're adding 4.
So 32 plus 4 equals
36.
36. Next we have 44. Does our rule change? No. So 44 plus 4 equals
48.
48. Our next input is 52. 52 plus 4 equals 56. So does everybody understand? When you create your own input-output table, you must have a block across the top with rule. You must have an input and output column that are labeled with the correct variables. And then you must have at least 4 terms. Yes, Zadie.
Isn't it 52?
52 plus 4?
Oh, I thought I was confused for a second.
No, 52 plus 4 is 56. Okay. Now, go ahead and keep going with number 2 and 3. If you need some extra, a little extra, that's okay. We're going to go back to number 2. If not, go ahead and go. And the homework. So, numbers 2 and 3 are just like the guided practice. Numbers 4, 5, and 6 are just like number 4. Numbers 7 and 9 are just like number 7 that we did together. Number 9 says, describe a pattern you see in exercise 2. That means number 2. Not example 2, but number 2. So the first one in the independent practice. Remember, the pattern you see cannot be whatever the rule is, or the inverse operation of the rule. Then look at the back. Numbers 10 through 13, you use the table on the side, plus the information, okay? You will need to write an equation. Make sure your variables are the same ones that the table gives you. You can't make up new variables unless there's none given on the table. But this table does have input and output variables. Use your formula from the guided practice to help you. Make sure you use units. If it's talking about money, make sure you have a dollar sign. If it's talking about taxis, make sure you write taxis. Number 14 is critical thinking with numbers. Number 15 is critical thinking with words. I am giving you printed homework, but it's going to look pretty much the same. So let's look at the homework. Numbers 1 through 4 are just like the guided practice. Numbers 1 through 4 on the homework are just like the guided practice. Numbers 5 and 6 are very similar to the back of the independent practice, where you're given a table and you answer questions about it. Numbers 7 and 8 are vocab. Number 9 is multiple choice. Make sure if you have to show work to the side that you do. But I am giving you printed math homework, so do not do the one in the book. I'll give it to you as soon as I'm done doing number 2 and 5. Okay? Yes, Mason.
Can I go get some water real quick?
Super quick, okay? I'm going to go ahead and talk about number 2, so make sure that you're back. Okay, who's helping me? Lena's helping me with number 2, and then Zadie's going to help me with number 5. So, number 2 says, if you're ready, just keep going. Write an equation that describes the pattern. Then use the equation to find the next two output numbers. So Lena, let's use our formula to write what we can of the equation. What do we know is going to go first?
M
Because what goes first?
is an input.
So which variable always goes first?
M
The input variable. Do we know what comes second yet? Without looking deeper? No. So we're going to save some space. What do we know goes last?
N
N. Why does N go last?
because it's the output.
Because it's the output variable. And what goes right before the output variable? An equal sign. Now we just have to find the,
The answer.
look at your formula so you know what goes in the middle on the guided practice where we wrote all those notes.
The rule in the middle.
The rule. So we have to find the rule. Okay? Our input is 11, our output is 2. What did we do to 11 to get 2?
We subtracted 9.
We subtracted 9 because if we counted backwards, we would start at 11, end at 2, and figure out how many fingers. But do we put a finger up for the number we start on?
No.
No. So 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. So that means we counted back 9, which means we did subtract 9. Now, should we automatically say that's the rule?
No.
No, let's check. Is 16 minus 9 7? Let's test. 16, 15, 14, 13, 12, 11, 10, 9, 8. So, is 16 minus 9 7?
Yes.
Yes. So that's probably our rule, but let's check one more time. Is 21 minus 9 12? Let's check. 21, 20, 19, 18, 17, 16, 15, 14, 13. So is 21 minus 9 12?
Yes.
Yep. So that means what goes in the middle?
9. Minus 9.
Minus 9. Good. So now we have to solve for the rest of the blanks. 26, what are we doing to 26?
Subtracting 9.
So 26 minus 9 equals,
N. Well,
but what will it be? We're replacing n with something.
it'll be 17.
17, let's check. 26, 25, 24, 23, 22, 21, 20, 19, 18, 17. Okay, now what do we do to 31?
Subtract 9.
So 31 minus 9 equals
22.
22. I noticed that when I subtract 9, I always end up with one more than like whatever 10 less, right? Maybe I can use that in the future when I'm trying to do math quickly, like addition and subtraction. Okay, Zadie, number 5. So we have our rule. V minus 11, is that an 11?
Yes.
Yes. V minus 11 equals W. V is our input, W is our output. So we know 16 minus 11 equals 5. So now we just have to keep going, right?
Yes.
What are we doing to 22?
We're subtracting 11.
So 22 minus 11 equals
2.
we might have to solve to the side. So let's do 22 minus 11. 2 minus 2 is,
2 minus 2.
I'm sorry, 2 minus 1 is,
1.
2 minus 1 is, so 22 minus 11 equals 11. Now if we can subtract just place by place, we can do that without having to solve. Because we know, okay, in the ones place, 2 minus 1 is 1. In the tens place, 2 minus 1 is 1. So let's try that again. What are we going to do to 28?
We're going to subtract 11.
So 28 minus 11 equals, so 8 minus 1 in the ones place.
8 minus 1 is 7.
In the tens place, 2 minus 1.
1.
So 28 minus 11 equals,
7.
there you go. Now 34. What are we doing in 34?
We're subtracting 11.
Subtracting 11. 34 minus 11 equals, let's look at the ones place, 4 minus 1,
Is 3.
tens place, 3 minus 1 is,
2.
so 34 minus 11 equals
23.
23. Now 40. 40, what are we going to do to it?
We're going to subtract 11.
Minus 11 equals, we can't do place by place. So we can either do it to the side, or we can think this way. What's 1 less than 11?
10.
And what's 40 minus 10?
30.
But now we have to do one more because we didn't subtract all 11.
So it's 29.
There you go. Okay. Go ahead. If you have questions, please come and ask me.